Welcome to my YouTube channel. Today I will share top most expected question of TOC. So now let's start. Question 1 is consider the following language over A comma B. L1 is A and closure of A comma B, and L2 is equal to B and A comma B plus. So if L is equal to L1 union L2, then which of the following is correct language? So if I union of this language, we will get A plus B. We will get C option because it will generate A and it will generate B plus A bracket A plus B also. So for L1 only generate A, so A here and B and A plus B also, so it will generate BA and BB also. So for this question option C is correct. Now next one is consider the following grammar G. These are the grammar. Here S is the start symbol and A comma B are terminals. Which of the following is correct expression for grammar Z? So we will see that in grammar yes goes to BS production, so it will generate B star because these are the this is the yes production BS, so it will generate B star, and it also go for A, and A generate A comma A B, so it only generate one time, so B star and A, and B goes to B comma B, so it will also generate B star and go for C also. Then when C goes to A comma D, AD, so it will generate A only one times A, and D generate B star many times and then epsilon. So this grammar is generate B star A, B star A and B star. So for this question option A is correct. Now next one is which of the following language generate the same regular expression? So from this language C and D generate same regular expression because if W in W we will put on place of W epsilon, then X generate AB plus, it means A not epsilon, A plus B, and then so on up to infinite. So and option D also generate AB plus A comma B plus. So C and D are same regular language. So in this way I solve this one. Now next one is this is chart. Mm, This is chart which can help you to better understanding which one is decidable, undecidable. You can learn from here. Now, which of the following problem are decidable? So does a given program ever produce an output? This is the problem of halting Turing machine, in which I cannot say that program at a particular input go to all inputs, not particular inputs. All inputs go produce output or halt at the input, or maybe in finite loop, so I cannot decide. So does a given program ever produce an output? It is a undecidable problem. If L is a CFL, then is L complement also CFL? L complement is not CFL because L complement is not CFL. You can see the table. If L is a regular language, then N is then is L complement also regular? Yes, complement is closed under regular, but in CFL not closed. So L complement of CFL not CFL, and L complement of regular is regular. If L is recursive language, then it L complement also recursive. L complement is closed under recursive. This is true. 3 and 4 are decidable. Option D is correct for this question. Now next one is, this table help you to understand which one is decidable and undecidable. Now question 5. Definition of language AL with alphabet A is given as following. L is equal to A power of nk, k greater than 0, and n is positive integer constant. What is the minimum number of state? So it will take n positive integer, so it will take minimum number of DFS is n plus 1, minimum number of state n plus 1, because why k plus 1 not, why k plus 1 is, why not k plus 1 is, because k is an integer, it will go 1 2 3, but n is a fixed, so its state is n plus 1. Option B is correct for this question. Now next one is, DFA with alphabet A comma B is given below. Which of the following finite state machine is a valid minimal DFA which accepts the same language as D? So it will ask for which one is minimum DFA. So minimum DFA, P goes to A, B goes to Q, and then A goes to yes. This is true. This is minimum DFA, and these are the not, because these are the accept A comma B same, but not at place of B, not a final state, because B from not final state on Q state. So this is the final state. This is not correct, and this one is also, this one is also. So for this question, option A is correct. Now next one is question 7. Let W be any string of length n is, these are the symbols used. Let L be the set of all substring of W. What is the minimum number of states in a NFA that accept L? Any string n of length n, so for length n, number of state will be n plus 1. Option C is correct for this question. Now next one is question 8. Which of the following language over the alphabet is described by the regular expression? So from the language I will see here, these are, when we put epsilon here, epsilon here, epsilon here, we will get 0. It means at least 2 0 are definitely. So the set of all string containing the substring, not substring, at least 2 0. So option C is correct for this question. The set of all string contains at least 2 0. Option C is correct for this one. Now next one is, consider the following language. Which one of the following statement is false? This 0 power P, 1 Q, and 0 power R. P, Q are greater than 0. So it will like a 0 star, 1 star, and 0 star. So it is a regular grammar. And this one is P, Q, R greater than 0 and P not equal to R. So it is a CFL. It is CFL, and L2 is CFL. This is true. L1 intersection L2 is CFL. Intersection of CFL and regular is CFL. Complement of L2 is recursive. Complement of this is also true. Complement of L1 is CFL but not regular. This is false. Option D is correct for this one. Now next one is, which of the following pair have different expressive power? DFA and NFA have same power. DPDA and NPDPDA have different power. Deterministic single Turing machine and non-deterministic single tape Turing machine have same power. So option B is correct. DPDA and NPDA have different power. Now next one is, let P be a regular language and Q be a CFL such that Q subset of P. For example, let P be the language represented by regular language P star Q star and Q be P and Qn. Then which of the following always regular? So it will ask for regular. P intersection Q is regular. No, this is not regular. P minus Q is regular. P minus Q. This is also not regular. And A comma B star minus P. This is regular because it generates Q star P. P star Q star Q plus P plus. Q plus P plus. So this may be regular. C, option C is correct for this one, and this one is not regular. So option C is correct for this one. Now next one is question 12. Consider the language L1, L2 and L3 as given below. L1 is OP1P, this is regular, and OP1P, P is equal to 1, this is DCFL, and PQR is equal to, this is CSL. Which of the following statement is not true? PDA can be used to recognize 1 and 2, L1 and L2. This is true. PDA used. L1 is regular language. This is also true. All the three languages are CFL. No, this is not true. Turing machine can be used to recognize all the three languages. This is true. Oh, option C is correct for this one. Now next one is, consider the language L1 0I and 1 I not equal to J. This is CFL. This is a CFL, and L2 0I is equal, this is DCFL, and this is also DCFL, and this one is also, this is one is CFL. So only L2 is CFL, only L2 and L3 is CFL, all are CFL. Option D is correct for this one. Now next one is question 14. The language generated by the above grammar over the alphabet A comma B is the set of. This goes to A as A production and B as B production and then A and then B. So it will generate all odd length palindrome because same symbol are both sides. So it will generate all odd length palindrome. So option B is correct for this one. Now next one is question 15. Which of the following statement is are false? For every non-deterministic Turing machine there exists an equivalent deterministic Turing machine. Turing recognizable language are closed under union and complementation. This is not true. These are the equivalent. This is true and this one is not true. And Turing decidable language are closed under intersection and complementation. This is true. Turing decidable language. Turing recognizable language are closed under union and intersection. This is false. So option 2 and 4 are false. 2. No. Turing recognizable language are closed under union and intersection. This is true. Only option 2 is false. Only 2. Only 2. Turing recognizable languages are closed under union and complementation. So for this question, question number 2 is correct answer. Option 2 is correct answer. Now next one is question 16. Let APP is a prime number, then which of the following is true? So for this one, it is not a substrate by Turing machine. No, this is a subset by Turing machine. B. It is regular but not CFL. This is not regular. It is CFL but not regular. It is CFL. This is also not a CFL. D. It is neither regular nor CFL but accepted by Turing machine. This is true. Option D is correct for this one. Now next one is question 17. Consider the following types of language. L1 regular, L2 CFL, L3 recursive, L4 recursive in Revel. Which of the following is are true? L3 complement union L4 is recursively enumerable, and L3 complement complement of recursive is recursive. So is recursive enumerable? This is correct. L2 union L3 is recursive. L2 union L3 is recursive. This is correct. This is all also correct. And L1 star union L1 star regular and union L2 CFL is CFL. May not be. First, second and third is true, and fourth one is not true, because complement of CFL is not CFL. So this is not context free. So first, second and third is true. Option D is correct for this one. Now next one is question rating for any two language L1 and L2 such that L1 is CFL and L2 is recursive enumerable but not recursive. Which of the following is unnecessarily true? L1 complement is recursive. This is true. First one is true. L2 complement is recursive. L2 complement, this is not true. L1 complement is CFL. This is not true. L1 complement union L2 is recursive enumerable. This is true. 1 and 4 is true. So option D is correct for this one. Now next one is which of the following is are undecidable. So for decidable and undecidable, I will provide the table here. You can check here from which one is decidable and which one is not undecidable. So now G is a CFG is LG is equal to 5. This is a emptiness problem. So for emptiness CFG is decidable. So this is a decidable problem, and for completeness CFG is undecidable. For completeness is CFG is undecidable. M is a Turing machine. Is LM regular? For Turing machine for regularity is undecidable. And A is a DFA and N is a NFA is L language A is equal to language N. This is a decidable problem. Option 2, option 3 is undecidable problem. So option D is correct for this one. Now next one is consider the following two statements about regular language. Every infinite regular language contains an undecidable language as a subset. This is true. Infinite regular language contains an undecidable language. Every finite language is a regular. This is also true. So for this question, both S1 and S2 are true. Option C is correct for this one. Now next one is, for a Turing machine denotes an encoding M. Consider the following two languages. M takes more than 2020 steps on all inputs. M takes more than 2021 steps on some input. This is the problem in which ask only on all input it takes 2021 step or more than. So when it is less than or equal to 2020 steps, says it takes less than or take more than, it will, I will give the answering yes or no. So this is a decidable problem and this is also decidable problem. So option A is correct for this one. Both L1 and L2 are decidable problem. Now next one is, which of the following problems is undecidable? To determine if two finite automata are equivalent. This is decidable problem. Membership problem of CFL. This is decidable. Finiteness problem for finite automata. This is decidable. Ambiguity problem for CFL. This is undecidable problem. So these are the top question of TOC. For later update, please follow, comment, like and share my channel. Thank you.